Richard James will begin these tutorials on factorization with Factorization Tutorial 1A. In Richard James Mathematics Resources, we have comprehensive discussion on factorization. We will not bother with the warm cosmetic introduction here. In the vast majority of problems that are solved in these tutorials, all of the intermediate steps are left out, as we can see right here. This is because their inclusion is not necessary. We will not get any more marks for them. Only the essential steps are given on the answer sheet. So here we have only the essential steps, the steps that are enough to convince the marker that we know exactly what we are doing. Some expressions are factorized in one step. Usually, they attract only 1 mark in the examination, which is an indication of the number of steps that we need to take. Those will be explained in details in these tutorials. However, in these tutorials, it is my intention to explain each step, including the intermediate steps. I will ensure that no step is left unexplained. Do not worry about the cumbersome expressions and the level of sophistry that may be present in the appearance of some of these expressions. They will be explained. So one should not worry about the level of sophistry that may be present in the appearance. So they will appear very sophisticated, but in the end we will prove that they are not really very difficult. One frequent question that students ask is, how do we know what method of factorization is applicable to a particular expression? We will answer that question by making use of an analysis of every expression that we will factorize. At the end, you will not remember that you had any difficulty figuring it out. Students usually ask, how do I know that this one is a trinomial? How do I know that I factorize this one by grouping? How do we know that this one is a difference of 2 squares? How do we know that we just need to take simply a common factor? All of those will be explained. As a matter of fact, with the repetitive nature of these tutorials, students will be seeing trinomials occurring quite often, difference of 2 squares coming quite often, and not only that, we will be aware of the composition of each type of expression, and we will no doubt be presented with the different methods that may be used in factorizing each one. This first expression is in the form of a quadratic expression. It is quadratic because it has 4 terms. The examiners designed expressions of this nature to be factorized by grouping. Now, the examiners design expressions of this nature. That means when we see an expression like this in the examination, one that has 4 terms, we are to be aware that what we have there is not just any 4 terms, but we have an expression that has a special design, one that we should be able to factorize by grouping. In factorizing by grouping, we factorize the terms 2 at a time. Also, we need to be mindful of the fundamentals of factorization. The fundamental of factorization is we first take the highest common factor of the terms and divide each term by the highest common factor. Of the first pair, the highest common factor of the first pair is that maximum expression that can divide into both a squared and ab. That maximum expression is a. For the second pair, that maximum expression is negative c. And we are saying negative c, we can obviously see that c is common in the two terms. We can see it right here. However, we are opting to use as our common factor in this particular case because usually for the second pair we use the sign of the first term. So we take in this particular case a common factor of a. No doubt, because of the absence of a sign, we are sure that what we are taking as the common factor is positive a. And the first term that we have here is a squared, which is actually positive a squared. For the second pair, our first sign that we have is a negative. Therefore, when we choose a common factor, in this particular case c, we should use the sign that begins the second pair, and that sign that begins the second pair is negative. So we will use negative c as our common factor in this particular case. For the first pair, the HCF is a. So the highest common factor is a. So we take our common factor of a. Each term is then required to be divided by the highest common factor. That is how we factorize. We take the highest common factor, then we divide each term by the highest common factor. The highest common factor is a. Each term will be divided by a. As we said before, for the other pair, the second pair, as a matter of fact, the highest common factor is negative c. So we take out our negative c as the highest common factor. And what do we know? Each term will be divided by the highest common factor, which is negative c. So we will proceed to divide. So we have a squared is equal to a multiplied by a. Therefore, if we divide a squared by a, one of the a's will cancel. So we have the common factor preceding the brackets. A into a squared is a, and for the second term, the a's will cancel, as we see right there, and b remains. But we cannot neglect this negative sign that we have right here, which is the sign that separates the two. So we should really have a negative b. We will do the same with the second pair. We already have our common factor of negative c, and we are dividing each term by negative c. we are dividing by a negative term. We are dividing by a negative term. We therefore need to give special consideration to the sign, which is negative in this particular case, or give special consideration to all of the signs, because we will have a nice mixture of signs, and we need to know the result of manipulating the entire expression. So we have negative divided by negative is positive, therefore the C's will cancel and we have a positive A. Here we have positive divided by negative, the result is negative, therefore we should have a negative B right there. So we have positive divided by negative and the result is negative, so we have a negative B. We should also be mindful that if we are at this stage in factorization by grouping, and we, for argument's sake, we have a negative sign enclosed in these brackets, and in the other one we have a positive sign, then that means that we would have made a mistake somewhere, and we need to retrace our steps to ensure that we would have done the right thing. Because if further factorization is not possible, as a matter of fact, I cannot remember seeing an expression in which when we get to this stage and we need to factorize by grouping, and then there's no further factorization possible. And as I said before, the expressions in the examination that we will see that contain 4 terms are specially designed to be factorized by grouping. Therefore, with that special design, we expect that further factorization should be possible. We obviously have a common factor in the new expression. Notice that it is the same expression that we are transferring from this slide, which is the result of taking the first step of factorization that we have right here. And here is where we are at. We will move to the next slide and complete the process so that we will have this final step as the result. So we obviously have a common factor in the new expression. We will factorize further. The common factor, as we can see, is A minus B. We have A minus B right here, and we have A minus B right here also. So take our common factor of A minus B. So we have A minus B as our common factor, and as usual we will divide by our common factor of A minus B. And what do we know? Those will cancel and we will have the same thing there. Do not forget that we always have to include this common factor of A minus B, and what will remain after the reduction of the fractions inside of this large pair of brackets is A minus C. That's the only thing that is left, and that is why we have it right here. In the examination, or sometimes students are instructed that when we get to this stage, we just write down 2 factors. One will be A minus B and the other one will be A minus C, and that's all there is to it. It is the purpose of these tutorials to explain and to demonstrate how we arrive at the expressions that are enclosed in brackets. So we know that it is mathematics and not mathemagic. In an examination, the instruction is usually factorize completely. It therefore means that if we have factorized an expression and further factorization is possible, we should not stop until we cannot factorize any more. So Factorize completely means that we will factorize, and if we have common factors, we take common factors, and after taking common factors, if we have more common factors, we take common factors again. But normally in the CXE CSEC examinations, we should not see anything requiring us to go beyond 2 steps of factorization. Not that the expression will take 2 steps to factorize, but we will have, say, 2 stages of factorization. That is what we should have at most, where we have taken a common factor and then we will take common factor again. The next expression is in the form of a trinomial, 3 terms. And as we have right there, it is also called quadratic expression. Where are the 4 terms? So, this one, a trinomial, 1, 2, 3, also called a quadratic expression, and we know that quad is in relation to 4 terms. Our question is, where are the 4 terms? The answer is, the 2 middle terms are like terms and are therefore combined to form 1 term. And we will see an explanation of this in Richard James Mathematics Resources, Volume 1, Algebra, in the instructional material, that is. So, we have a trinomial called a quadratic, and we need to know where we may find the 4 terms, because this surely is not quadratic in its appearance or form, but it is actually quadratic. And the answer is, it is quadratic. However, the 2 middle terms are like terms and are therefore combined to form 1 term. In order to factorize a trinomial, especially one in which the coefficient of the term in the square of the variable is not equal to 1, we need to resolve that single middle term into its 2 components. So this middle term is comprised of 2 like terms, and those 2 like terms are combined and present in this single term that we have right here. So in order to factorize this expression, we need to resolve that middle term into its 2 components. And we will go through our process in doing so. Although we will not have it throughout the entire tutorials, it is important that we understand that a trinomial, well, we make reference to a trinomial as being of the general form a something squared plus b something plus a constant. Maybe we will have the general form, because it is usually in x, ax squared plus bx plus c. Now we are saying, because it is a quadratic or trinomial in y, we are saying ay squared plus by plus c. There we have a general representation of the above trinomial, which is this one, and this is a representation of it. We need to determine the 2 numbers that will give the same product as AC, and whose sum is B. Those will be the 2 coefficients of the middle terms. And as I said before, we will always allude to this general form, but we will not see the general form occurring throughout the tutorial. So we will always talk about A, C, which is multiplying A by C, and we will always make reference to B. But we will not necessarily place the general form there. But we will always, as long as we are factorizing a trinomial, we will always be making reference to this general form. So in order to transform this trinomial, which is actually this trinomial, to an expression that has 4 terms, we need to determine the 2 numbers that will give a product of A times C. So the product will be this times this, which 2 number has the same product as when we multiply 6 by -8. And when we add those 2 numbers, the result is positive 13. We will take a look at that on the next slide. We therefore need the 2 numbers that will give the same product as 6 times -8, which turns out to be -48, and will give a sum of 13. We need those 2 numbers. They will give a sum of positive 13, but when we multiply them, we get the same result as -48, which is the same result as multiplying these 2, and the sum of those 2 numbers will be this one here, positive 13. What are those 2 numbers? The fact that the 2 numbers multiply to give a negative value tells us immediately that the 2 numbers have different sign. So as long as they multiply to give a negative answer, the 2 numbers must have different sign. So we are multiplying 2 numbers that have different sign. Now we will be adding those 2 numbers that have different sign, and the answer is positive 13. So we know that if we are adding numbers with different sign, we subtract the smaller from the larger, and the answer will take the same sign as the larger. That tells us that of the 2 numbers that are different in sign, the larger one has to be positive, because when we add them, we get a positive result. Therefore, we are sure that they are of different signs because the result of multiplication is negative. We are sure that although they have different signs, the larger one is positive, because when we add them, subtracting the smaller from the larger, the result is positive. So the fact that the 2 numbers multiply to give a negative value tells us immediately that the 2 numbers have different signs. When we add numbers that have different signs, we subtract. Whatever the 2 numbers are, we have a subtraction problem, because they have different signs. When we add them, as a consequence, we will have a subtraction problem. Additionally, when we subtract numbers that have different signs, the answer takes the same sign as the larger. The result is positive 13. Therefore, the larger one is positive. Among factors of 48, we need a result of positive 13 by subtraction. Why subtraction? Because they have different signs. When we add numbers with different signs, we subtract the smaller from the larger. How do we know that they have different signs? Because we multiply them and the result is negative. They have to have different signs. Let us take a look at the possibilities. There we have all of the pairs of numbers that will multiply to give 48. But we are sure that what we really want is negative 48. Therefore, we are sure that because the result is negative, we have a subtraction problem. Also, that when we add the two numbers, which will turn out to be a subtraction because the signs are different, the answer is positive. Therefore, the positive sign is the sign of the larger. From the pair of factors of 48, which pair gives a difference of positive 13? Surely 16 minus 3 is equal to 13. So a positive 16 and a negative 3 will therefore be the two coefficients of the middle terms. They multiply to give a negative 48. They add to give a positive 13. The sign of the larger has to be positive because the answer is positive. So we have our two numbers right there, 16 and negative 3. Those will be the coefficients of the two middle terms. So instead of having a positive 13y, we have from this 16 we have a positive 16y, and the other one is negative 3, so we have a negative 3y. So we have resolved the middle term into its two components, and we will continue to factorize. We have converted the trinomial to its quadratic form, and we may continue to factorize the expression by grouping. Recall some details, that is, some details of factorization. The product AC is negative. This is the result of multiplying numbers with different signs. So the product of AC is negative. Because it is negative, we are sure that the two numbers have different signs. The problem is therefore a subtraction problem. The result is positive. When we subtract numbers that we really intend to add, so we really intend to add those numbers because they are of different signs, we have a subtraction problem. The result is positive. Therefore, of the two numbers that have different signs, the larger one is positive. And we will factorize by grouping as we did in the first expression. So we have completed the first step, which is to resolve the middle term into its two components that we have done right here, and we will continue our first step of factorization by taking the highest common factor of the first pair. So we are factorizing by grouping, taking two at a time. So we need for these two, the highest common factor. And the highest common factor of these two is 2y. So we take 2y out as our common factor, and then each term that we have here will be divided by 2y. What do we do? Go to the next pair, and what do we say? The second pair has no common factor but 1. That pair begins with a negative sign. We will use negative 1. As we see, there is no other number apart from 1 that can go into 3 and 8. And there is surely no letter or symbol that we have that is common here and here. So our common factor is 1. But in the custom of using the sign that begins the second pair, we will factorize by taking a common factor of negative 1. And we will divide, as usual, each term by the highest common factor of negative 1. Always in algebra, pay very special attention to the signs. As a matter of fact, that is the reason for Richard James Mathematics Resources having in its instructional material working with positive and negative signs as the first topic. It is so important, and you will see throughout algebra how important it is for us to be able to manipulate signs correctly. So we have here our common factor that we have taken, and we will write that down right there. So we have our common factor, and that will always be in our expression. So when we go to the next step, the common factor of 2y is present. What we are looking at right here is the intermediate step, the one that takes us from this to this. So we are right here looking at this, and we are about to write down this step, but we are looking at the process that takes us from this step to this step, the finer detail of that process. So we have dividing, of course, each term by the highest common factor. As you can see, these are the terms that we are using, dividing by the highest common factor. 2 into 6 is 3, y into y squared is y. 16y divided by 2y, the y's will cancel. So we have 3y there, and of course the y's will cancel, and 2 into 16 is 8. Over here, what do we have? Well, we are dividing by a negative 1. Well, if we are dividing by 1, the numbers will be exactly the same. Only the signs that we need to adjust. So, negative into negative is positive. Negative into negative is positive. So we will have a negative 1 for our common factor here. And each term in the brackets will be positive. So we are dividing by a negative term. We therefore need to give special consideration to the signs. In both cases, negative divided by negative is positive. There we have it. So we have completed the process, and we are at this step, and we need to see how we move from here to here. That we will do on the next slide. So we will take the common factor of 3y plus 8. No doubt 3y plus 8 is a common factor, as we see right here. 3y plus 8 is our common factor. So we take the common factor of 3y plus 8, and what do? We divide by the common factor of 3y plus 8. So we will then divide each term by the common factor of 3y plus 8. What else? Those common factors will cancel, and that will also cancel, reducing the fraction, and all that we have left is this 2y and this negative 1. So we have 3y plus 8 in one pair of brackets, and in the other pair of brackets we have enclosed 2y minus 1. In an examination, the instruction is usually factorize completely. It therefore means that if we have factorized an expression, and further factorization is possible, we should not stop until we cannot factorize anymore. Factorize completely, factorize till there is no other possibility or prospect of factorization. But in this particular case, we have exhausted all possibilities, so we are at the end of it. Here, we are required to solve a quadratic equation. We have another tutorial on solution of quadratic equation, but we will still solve the equation here. I always welcome deviations from the norm. We should have no reservation because it is still mathematics. So although in these tutorials we have thrown in a quadratic equation, and we are not really solving equations in this tutorial. We are factorizing expressions. But it's here, and it is mathematics, so we will continue, and we will factorize the expression if needs be. Well, the expression that we have here is the same one that we have already factorized, so we do not need to do that. We just continue by finishing up the solution of that quadratic equation. We are required to solve the quadratic equation, which is the same equation, well, the equation that is making use of the expression that we have factorized already. There are a few methods that may be used to solve it. The one of choice is by factorization, which is the easiest, as long as the expression can be factorized, and especially that we have just completed the factorization process. So, factorization is usually the easiest way to solve a quadratic equation, that method by factorization. And it is made a lot easier because we have factorized the expression that is involved in this equation. Solve the quadratic equation. 6y squared plus 13y minus 8 is equal to 0. Solving that equation is the same as solving the equation with the expression on the left hand side already factorized, because this expression is equal to this one, only that it represents the factorized form of the one that we have right here. The premise on which we solve a quadratic equation from its factorized form is that if two numbers or expressions are multiplied together and the result is 0, then at least one of them is equal to 0. It may also be that both of them are equal to 0. Since we are not capable of making that distinction, we have to make provision for both of them. The contents of the brackets are being multiplied. We will consider the result of equating each of them to 0. Do that on the next slide. The product of the two expressions is equal to 0. So when we multiply this by this, the result is 0. What does that tell us? That tells us that since we have two things, numbers, expressions, symbols, as long as they are being multiplied and the result is 0, it tells us that at least one of them is equal to 0. But since we do not know exactly which one is equal to 0, we need to make provisions for both of them by equating both of them to 0. So one or the other or both must be equal to 0. We will solve this equation and we will solve this equation. This is a linear equation and this is also linear. In the first case, 8 is added to the left hand side. Notice, accompanying the unknown that we are attempting to find is a positive 8. 8 is added to that left hand side. We will therefore subtract 8 from both sides, thereby eliminating 8 from the left hand side, and on the right hand side we will have negative 8. So we need to eliminate this positive 8 by subtracting 8, but we cannot do that to one side alone. We have to do it to both sides. In that event, 8 will be eliminated from the left hand side, and on the right hand side we have a negative 8. For the other one, we have a negative 1 accompanying this term that contains the unknown that we are attempting to find. In order to eliminate this negative 1, we will add 1 to this side and add 1 to the other side also. Negative 1 plus 1 is 0. The negative 1 will therefore be eliminated from that left hand side, and on the right hand side we will have a positive 1, as we have seen right here. So in the second one, we have eliminated that negative 1, as we have explained. So the two equations are now 3y is equal to negative 8 and 2y is equal to negative 1. And we need to eliminate this 3 that is being multiplied here and this 2 that is being multiplied there. In each case, y is multiplied by its coefficient. We will therefore eliminate the coefficient by division and do the same on the other side. So eliminate 3 that is being multiplied by y, or we say that y is being multiplied by 3 and we need to eliminate 3, so we will do that by division. Cannot do that on one side only, we do that dividing by 3 on both sides. Here we need to eliminate 2, and we will do that by dividing by 2 on both sides. And we will realize that the 3's will cancel here, and on the right hand side we have negative 8 over 3. Here the 2's are eliminated and we have a half. So y is equal to negative 8 over 3 or a half, or both, because we are sure that if, as we have right here, this one is equal to 0, then y is negative 8 over 3. If this one is equal to 0, then y is equal to a half. The result is 0. We do not necessarily need both of them to be equal to 0, but we are sure that one or the other or both. So we have not left any room for any doubt. We have made use of equating both of them to 0. So y is equal to negative 8 over 3 or a half. That is all there is to it. When solving an equation by factorization, each factor should be equated to 0 and the roots will be the solution of the entire equation. That is, when we equate them to 0 and the results that we get, that will be the solution of the entire equation. My mathematics students are trained to write down the answer as soon as the expression is factorized. So when my students get to this stage, right here, they are trained just to look at this and write down the final answer without having to go through many steps afterwards. The other expression has two components. One is in the form of a difference of two squares, and the other may be factorized by simply taking a common factor. So let us see. We are saying if we can see that the expression is comprised of two other expressions. One is in the form of a difference of two squares, and then we have another part of it that may be factorized by simply taking a common factor. Where is the difference of two squares? There we have them. And then the other portion, we will take a common factor. So we will factorize the difference of two squares first. In factorizing the difference of two squares, find the square root of the two squares. So we have two squares here, x squared and y squared, and those are in a difference of two squares. They are a difference, or representing a difference of two squares, because we have this negative sign here that tells us that we are subtracting. Subtracting is the same as finding the difference. So that is what we are doing right there. So we are factorizing that difference of two squares by taking the square root of the squares. So one is x squared. When we find the square root of x squared, we get x. We find the square root of y squared and we get y. When we square x, we get x squared. When we square y, we get y squared. When we do the reverse, taking the square root of x squared, then we should get x. They are separated by a positive sign in one pair of brackets and a negative sign in the other, and the signs may be in any order. So the negative goes first and the positive second. It may be that you want to put the positive first and the negative second, but irrespective of your choice, the answer is correct. So when we find the square root of x squared and the square root of y squared, they are enclosed in brackets in this fashion. Both of them enclosed in one pair. Those are also enclosed in the other pair of brackets. And then we will separate them by a positive and a negative sign, like that. And we will be factorizing so many expressions in the form of a difference of two squares. At the end of these tutorials, we should really get it. Now, in the second case, take a common factor of negative 4 and divide each term by the common factor as usual. So when we take a common factor, we generally divide by the common factor. So the common factor is negative 4 that precedes the brackets, and we will divide each term by negative 4. What do we know? Negative divided by negative is positive. So we will have a positive x. And negative into positive is negative. So we should have a negative y there. So we have a positive x and a negative y. Negative into positive is negative. Yes, as we have there a reminder that positive divided by negative is equal to negative. Positive divided by negative is negative. We may continue to factorize by taking a common factor. And as we have it written there, we may continue to factorize by making use of the large factor x minus y. So our common factor is x minus y. So what do? Always when we are factorizing, we take the highest common factor and divide each term by the highest common factor. So take our highest common factor, and here we have the terms. We will divide them by the highest common factor, and no doubt we see them cancelling, and we see them cancelling. Now, maybe just by looking here, it looks magical getting from here to here. How do we know? This thing appears to come from outer space. We just write down x minus y, and in the other we put x plus y minus 4. In the examination, that is acceptable. This is enough to demonstrate to the examiner that you know exactly what you are talking about. However, in order that you know how to arrive at it, And if you see this in the tutorials, you will understand how I arrive at it by these intermediate steps. So these intermediate steps are included in order that the students will have a very good understanding of the process in arriving at this answer, so that you can also make that step mentally. Well, I'm sure that maybe a lot of students are capable of making the steps mentally, but at the end, I am also sure that for some students, they will do quite a few things without understanding exactly why they do it or why they do them. So the intermediate steps are there to explain them in detail. So what do we have here now? These are eliminated and we have x plus y right there. These are eliminated and only the negative 4 remains. In the end, the brackets do not count for much in this particular case, because I cannot say that they are insignificant, because we will see cases in which we will see cases in which they make, or their presence makes a big difference. So in this particular case, the brackets are not affecting the expression, so we may just eliminate them. So all we have is x minus y, x plus y minus 4. We will have other cases in which the brackets will be eliminated from the expression, but they will be significant to the extent that we will require further manipulation of the expression. We will do that. Like in the one that we have right here, that we are not there as yet. When we get there, we will cross it. In an examination, the instruction is usually factorize completely. As long as we have common factors in the expression, we are required to continue factorizing. So we have said that on a few occasions, maybe in the other tutorials in this section, we will not be hammering at it so much, but I am sure that at this stage, it might be a little bit overbearing already, but at least you are aware of it at this early stage. What do we have there? This expression is analogous to the first. For the first pair, the HCF is A. Why we just say it is analogous and we just say the first pair has a common factor of A? Because we are again factorizing by grouping. And we are taking them 2 at a time. That is understood from the one that we have right here. And then, of course, after taking a common factor of these 2 terms of A, what do? We divide by the common factor. And then for this pair, what is the common factor? Well, we see P here and we see P here. And of course, 2 can go into 6 and 2. 2P is our common factor. But we usually use the sign that begins the second pair. So we will say a negative 2P is our common factor. So for the second pair, negative 2P is our common factor. Divide each term by the common factor, as usual. On this side, we can see the cancellation quite easily. Reducing by A, that one is pretty straightforward. So 3A divided by A, the A's cancel. 3 remains. AT divides by A cancels, the T remains. So we will have 3 plus T right there. In the other one, not so, well, it is not very hard to see, but maybe not so straightforward, probably because of the sign and probably because it does not cancel completely right there. But we can make light work of it nonetheless. We are dividing by a negative term. We therefore need to give special consideration to the sign. In each case, negative divided by negative is equal to positive. So we have taken out the common factor of negative 2p and we are dividing each term by negative 2p. Negative divided by negative is positive. Negative divided by negative is positive. 2 into 6 is 3 and the p's cancel. The 2's will cancel, the p's will cancel, and we have t. Can you remember what we had here? Negative into negative is positive. The p's cancel. 2 into 6 is 3. Negative into negative is positive. The p's cancel. T. So we have 3 there, and we have T there. With the presence of a common factor of 3 plus t, we will factorize further. So we have a common factor. Factorize further by taking that common factor of 3 plus t. And what do? Divide each one by the common factor. And what will happen? Those are gone. Those are gone. So we have left right there only a and negative 2p. So we have 3 plus t first, and then we have a minus 2p, and that's all there is to it. And for the 100th time, in an examination, the instruction is usually factorize completely. It therefore means that if we have factorized an expression and further factorization is possible, we should not stop until we cannot factorize any more. This expression is in the form of a difference of two squares, and as it is said, what else could it be? Because for sure we do not have any common factor with this term and with this large term that we have here. But that does not make it a difference of two squares. The fact is, 1 is a square, which sometimes eludes students, as we will take a look at in a subsequent tutorial. 1 is a square, and no doubt we have a plus b all squared there. That's a square. So we have two squares separated by a negative sign. We have a difference of two squares. How do we factorize a difference of two squares? In factorizing the difference of two squares, find the square root of the two squares. So 1 of the square is 1. Square root of 1 is equal to 1. 1 of the other square is a plus b all squared. When we take the square root of all of that, the square root and the square operation, they have a cancelling effect on each other. So all that is left is this a plus b. We will have them as usual separated by a positive and a negative sign. So we have 1 square is 1 and the other is a plus b. 1 and the other one is a plus b. We put different signs here So we are separating them by one a negative, one a positive. In the end, what do we have? This negative sign is distributed to A, so negative A, and it is also distributed to a positive B. Negative times positive is negative, but here positive times positive is positive, positive times positive is also positive. So we have the positives there, and no doubt we have negatives there. Negative times positive is negative, negative times positive is negative. In the first pair of brackets, the negative sign is distributed to each of those positive terms. Negative multiplied by positive is negative.